Hey, Algebra 1, we've been talking today about power rules leading into exponential functions. So all of the homework tonight is about power rules. Let's jump into it. There are 5 major rules we want to pay close attention to, and let's walk through them together. These are just 5 examples of things that you really want to pay close attention to. And what I did was I've really color-coded everything based on whether it's a coefficient idea, which is in red, or if it's a variable / exponent rule, which is in black. So let's start by doing the coefficient idea. In the first one, 7x squared times 8x to the fourth. This is 7 times 8, 56. Not anything new. But what is new, hopefully, is the idea of these exponent rules. X squared times x to the fourth, x times x times another 4 x's. Now you see that there's a total of 6 of them. So, for example, you do end up multiplying the coefficients, but the way you multiply powers is you really add the exponents together, which can be weird. You're multiplying, so you add. But that's because exponents already represent multiplication, so their simplification processes are a little easier. They're normally 2 steps down from what you've been doing. For example, adding is what you learned first in school, then subtraction, then multiplication, then division, then exponents. So if I am multiplying, let's go 2 steps down for the powers and let's add them together. Well, let's look at a case where you're dividing. So 5 over 15, first of all, that simplifies to 1/3. So that's nothing new. But what is new is this idea of powers. Because you are dividing, let's do 2 steps down for that, and we end up subtracting. So if you were to do 6 minus 10, that is x to the -4. Now what that's really trying to tell you is that there are actually 4 extra x values in the denominator, because if you think about 6 canceling with 6 on the bottom, there's still 4 left over on the bottom since there was more in the denominator to begin with. And this can be your final answer. Okay. So I just hit on another rule, that idea of a negative power, and that's kind of what we're seeing in the next one. 60 doesn't change, y to the third doesn't change, but this whole x to the -2 thing, this can be represented with a positive exponent if I was to move it to the opposite side and change its power to be a positive. Okay? Just like we were talking about in class, 3 squared is 9, but 3 to the -2 would be 1/9. So instead of multiplying by 3 twice, you're really dividing by 3 twice. So that's where negatives come in. Let's talk about power rules. You're putting a power on a power. So the hard one, I think, for a lot of students is seeing 6 squared, 36. A lot of times they blend the rules for exponents, and we want to be careful about that. So when you are powering a power, it really means you're going to end up multiplying. If I wanted to expand this, if you're saying that this is squared, that'd be 6xy to the third times another 6xy to the third. And so there's where you see 6 times 6, 36. But I see 1 and 1, I really see 2 x's there. And 3 and 3, I really see 6 y's there. But we could have gone a little faster starting at the beginning if we had understood I could multiply each of these powers together to get my resulting powers in the end. Lastly, anything to the 0 power is 1, except for 0. If you try to do 0 to the 0, you get undefined. So this isn't all 1. This really comes down to 16 times 1, which is just 16. So hopefully this is just a few quick examples before we jump into this. I'm going to do these middle 2 columns going down, and you can try the other side on your own. So the first thing I notice is that 6 and -3 are against each other, and in algebra that represents multiplication. 6 times -3, -18. However, if you are multiplying these variables, those would end up adding together, and that would be x to the 7th. The next one, just really pay close attention to that last one having a 1, but we are basically adding all these up. 3 plus 4 plus 7 plus 1. That ends up giving you 15. So that is b to the 15th power. 6 is not times 3, 18. No, that is 6 to the third power. And 6 to the third power is 216. Really want my students to understand this one. I see this one a lot in ACT review, so I think this one will really pay out for you if you can do that later. But these are going to end up multiplying, so 4 times 3 makes x to the 12th, and 6 times 3 makes y to the 18. Similarly here, I think I will just show expansion for this one just because I like to show different representations. If you're saying something is cubed, that means I am multiplying what's in parentheses times itself 3 total times. So that's 4x to the third, y to the third, times 4x to the third, y to the third, times 4x to the third, y to the third. Now this is unnecessary if you really understand how all the rules work. For example, at the very beginning, I could have said, what is 4 to the third power, which is the same as saying, well, 4 times 4 times 4 is 64. Okay, so just be careful. That is not 4 times 3. That is 4 to the third power, 64. Now the next thing is I had those x's, 3 and 3 and 3. That's making x to the 9th. However, I could have gone a little faster if I just multiplied 3 times 3. And in fact, I can do that for the y's to make it a little faster. Okay. I need to scroll down on that one. Scrolling down, first thing I see with division is the coefficients. 9 divide -3 would be -3. I think about the a's. The a's would have 3 minus 1, which would be 2. And because that came out to be a positive, I know it's going to be in the numerator. And then this last one, if I was to do -5 minus 2, you get -7. So that's like b to the -7 there. But really that's trying to tell me that there are 7 more in the bottom. In fact, I could show you how they move in the beginning. If I wanted to, I could say, hey, this was a negative power, so instead of it being in the top as a negative, I'm going to put it in the bottom as a positive. Well, then they're going together, 2 plus 5 to be 7. So either way, you should get -3a squared over b to the 7th. Negative divided by negative should be +6. Looking at the c's, I see 2 minus 1, which would just be 1. And 4 minus 1 would be d to the third. So in this case, the numerator is really all that I have. The denominator is just a division of 1. I really don't need to write dividing by 1 there. All right, let's go ahead and knock that one out. Anything to the 0 power is 1. That can be easy if you're a studier. That can be hard if you're someone that tries to memorize everything. Anything to the 0 power is 1. And so be careful on this one. This is not all 1 there. -2 to the 5th power. Because I have a negative raised to an odd power, I should expect a negative outcome. But let's say I had done it to an even, like the next number, if I had done this to the 6th power, I would have expected a positive. Okay? But anyway, -2 to the 5th is -32. So that's the first thing I do. And then I want to use multiplication. So -4 multiply 5. This would be x to the -20. So I like this one because it really helps us think about negatives a lot. You know, -32, we've been talking about negative numbers for a long time. Negatives are a new idea with exponents, but not just numbers in general. But the fact that x has got a negative power on it, I really want to write that in the bottom as a positive, but it does not affect that -32. That -32 is really to the 1 power, so it doesn't have a negative power and does not need to move. And 2 more here. I see a bunch of multiplication here, so 6 times 3 times 1, that's 18. And then if I start taking all these exponents and multiplying them together, well, if you're multiplying variables, you really add them together. So this is 5 plus 5 plus 0, which would be 10. And that would be the final answer. And 24, and let's really watch this. This is 3 to the 3rd power. That is not 9. That is 3 times 3 times 3, which is 27. S, be careful that S is to the first power, and 1 times 3 is 3. And then this last one is probably the one that most students are going to see pretty easily. 12 times 3, this should be t to the 36. Hopefully that was helpful. Take a look at some of the other ones on that far right side, and we'll go over what you got tomorrow and check your work. See you tomorrow. Peace.